Okay, today we're going to be doing the real number system, and this is just a way for us to group various categories of numbers. So the most basic group of numbers are the natural numbers, and those are our counting numbers, designated by the letter n. So we can say 1, 2, 3, 4, and so on until infinity. You'll see that those are the positive numbers starting at 1. Okay, so that is the most basic group. And then we move up, and the next group of numbers are the whole numbers, designated by W, and those include all of the natural numbers plus 0. So it's going to be 0, 1, 2, 3, and so on. Okay, the next group of numbers are the integers, and those are very similar to the previous two, except they include the negative numbers and all of the previous two groups. So negative, we might see negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Again, this would go on to negative and positive infinity. Sometimes we use the letter I, sometimes we use the letter Z to denote the integers, depending on the textbook we're looking at. Okay, so those are that's the next group. Then we have the rational numbers, and the rational numbers are sort of that column, the in-between numbers. They include decimals and fractions. So we might be looking at something like 2.5 or 3 over 4, etc. There's many, obviously, again, infinite number of possibilities there. And we use the letter Q to designate the rational numbers. All right. Now, the irrational numbers, the ones on the right here, are decimals that go on forever. In other words, they don't terminate, or they don't stop. So the most famous irrational number that you might have heard of is pi, and pi is 3.14, I think, 15, and that would again go on forever. I haven't really memorized the first few digits. Some people memorize more. But we have other rational numbers like the square root of 10. Well, if you don't know what the square root sign is, we're going to be learning that next class. But this would be, again, I have to get my calculator out here. The square root of 10 would be something probably close to 3, maybe 3.1. Let's take a look here. Yeah, 3.16. Again, the calculator ends here, but that number would keep going on forever. So 3.16, all right, 3.162, and then I'll put 3 dots to signify that it goes on forever. Okay, and then the real numbers include all of the, notice that the rational numbers are in a group on its own. They don't include any of the previous groups that I've mentioned. So, and they're designated also by Q, but with a line on top of it like that. Okay, the real numbers, they include everything that all the groups that we've talked about so far. Okay, I've included a diagram at the bottom here. It's probably a little nicer than mine, or if yours is better, that's great. Okay, the hard part here is distinguishing between the rational numbers and the irrational numbers, because they both involve decimals. So the simplest way to differentiate between the two groups is that rational numbers can be written as a fraction. So that's sort of their key feature there. They can be written. You can go ahead and highlight that. So a number like 0.25, we know that can be written as a fraction, 1 over 4. So the key thing again is that rational numbers can be written as a fraction. So any terminating decimal can be written as a fraction. If we took, doesn't matter, basically any number, 1.125 there, we can write that as a fraction, which would be 125 over 1,000, and then we would simplify that to a simpler fraction. On the other hand, the irrational numbers cannot be written as a fraction because they're not, again, they're non-terminating decimals. They keep going on forever. Okay? All right, now, a tricky number here. What about repeating decimals? Where do you think they go? Are they part of the rational numbers, or are they part of the irrational numbers? Because they kind of go on forever, which is a characteristic of our irrational numbers, but at the same time they can be written as a fraction. So let's just take one example. If we were to have 0.666 repeating, that can be written as a fraction, which is 2 over 3. And again, where do you think these sit? Which group do you think they sit in? Well, because they can be written as a fraction, we're going to put them in the rational group over here. So not the irrational group. That's kind of the only tricky one that we have there. Okay, hope you've enjoyed that. See you next time.